Good morning, everybody. Today we are going to do division with radicals. Okay, some of this you've done before with square roots, with cube roots, fourth roots, fifth roots might be a little bit different. That might be new for you, but most of this you have done before. All right, so our first example, all right, so this is day 4 division. All right, our first example is just something you guys have seen before, 3 over the square root of 5. All right, so what do we know we cannot have a radical in the denominator. So how do I get rid of that? We do that by multiplying the top and bottom by whatever is in the bottom, which is the square root of 5. And we multiply 3 times root 5, which is 3 root 5. And the reason that we multiply what's in the bottom, because I get 5 times 5, which is 25, and 25 is a perfect square, and it's a square root. So that's why multiply by itself, it always gives you a perfect square if you multiply something by itself. All right, so the square root of 25 is 5, and hopefully you guys know when you multiply the square root by itself, the radical just disappears. So root 5 times root 5 is just 5. Okay, but it is because 5 times 5 is 25, and that's a perfect square. And if you have a perfect square, then the square root disappears, and that's what we're looking to do. All right, so I get 3 root 5 over 5. All right, now for the second one, we don't have a square root, we have a fourth root, and it's the fourth root of 2/3. All right, so now I can rewrite this as the fourth root of 2 over the fourth root of 3. Okay, so just like you can't have a square root, you can't have a cube root, fourth root, whatever. You can't have any sort of radical in the denominator. So to get rid of that, your first guess is probably that let's just multiply what's in the bottom. That's what we did for square roots. Let's try the same thing here. So let me try that. So that would be the fourth root of 3 and the fourth root of 3. Okay. Now, if I did that, I would just multiply the top. Same root, so I just do multiply the inside. So it's a fourth root of 6. And what's 3 times 3? It's 9. But this isn't a square root. If it was a square root, great. Square root of 9 is 3. But this is a fourth root. Fourth root of 9 is just a fourth root of 9. Look, I didn't do anything to get rid of the radical, the fourth root in the bottom. So this is not correct. All right. So we have to think, what can we do? What are we going to multiply? We're still going to multiply the top and bottom. All right. But since it is a fourth root, all right, so we need to figure out, what am I going to multiply? I need to multiply by the fourth root of something, right? Here and here. What is my goal? My goal is to be able to cancel out the radical in the bottom. In order for me to do that, what has to be true? This number here has to be a perfect fourth, meaning some number to the fourth power. Well, I already have 3. I have 3 to the first. If I got 3 to the fourth, all right, that means I would get, what's the fourth root of 3 to the fourth? It's just 3. So what can I multiply 3 to the first by to get 3 to the fourth? Well, what if I multiply by 3 cubed, right? Because 1 plus 3 is 4. What's 3 cubed? 27. All right. Now, 3 times 27 is 81, and the fourth root of 81 is 3, but you don't really need to know that. You just need to know that this is 3 to the fourth. It is 81, all right? And then 27 times 2 is 54, all right? You can't simplify that because it's 27, which is 3 cubed times 2. Nothing has 4 in it, so you don't go anywhere. And now the fourth root of 3 to the fourth is just 3. So it is the fourth root of 54 over 3. And there's my answer. All right, so our goal is to figure out, what can I multiply the bottom by to give me a perfect fourth, or if this was a cube root, perfect cube, or perfect fifth, or whatever it may be. All right, so this number here was 3 to the first. I wanted 3 to the fourth. What did I need to multiply? 3 cubed, which is 27. All right. That's number 2. All right, number 3. All right, 3, we're back to a square root. All right, so why don't you guys go ahead and see if you guys can figure out number 3. So the first thing you should have done is you hopefully split it up to the square root of 5x over the square root of 2y. And then it's just a square root, so you multiply the top and bottom by whatever's down there. And the reason you do that is because I need to have a perfect square, which means I need to have this squared and that squared, which just multiply by itself again. That's all. All right, so I multiply by 2y on the top and the bottom. So I get the square root of 10xy. I can't do anything with that. That's a 10, not a 16, sorry. Over square root of 2y times square root of 2y is just 2y. All right, so let me write this a little better here. So the final answer is 10xy all over 2y. You cannot reduce the 10 and the 2. The 10 is in the radical. The 2 is outside the radical. These y's can't cancel. You can only cancel if it was multiplication outside and outside, inside and inside. All right, so there is number 3. All right, so number 4. We have another cubed root. All right, so we have the cube root of 5 over the cube root of 2b squared. Okay, so I need to figure out what do I need to multiply the top and the bottom by. All right, it's a cube root, which means I need a perfect cube to end up under here. Well, I have 2 and b, so I need to have 2 cubed and a b cubed, right? I want 2 cubed and b cubed. So I have in here a 2b squared. What would I have to multiply to be able to get that? Well, I have 2 to the first. I need a 2 cubed. So I need 2 squared, which is really, so I'll write 2 squared. But 2 squared is just 4. I have a b squared. I need a b cubed. So I need to multiply by b to the first. So you multiply by the cube root of 4b. All right, and you end up getting 5 times 4, so that's the cube root of 20b. Here I get 2 times 4, which is 8, 2 cubed, b cubed. All right, and that means I get, as a final answer, the cube root of 20b, which I can't do anything with, all over 8 square cube root of 8, which is 2, b cubed, which is b. Cube root of 20b all over 2b is your answer. All right, we had 2. You need to get a perfect cubed, which is 8. So I think it's easier to think of like you have 2 the first, you need 2 cubed, you multiply by 2 squared, which is 4. You have b squared, you need a b cubed, it's b. All right, so that's where we get these numbers from. All right, this one here, number 5. All right, we have another square root. Remember, this can be just rewrite it like 3 root 3 over 5 root 6. All right, why don't you go see if you can finish that one. All right, now what you can do first to this is, since these are both inside 3 over 6, this cancels to a 1, this cancels to a 2. What's the square root of 1? It's just 1. So I can make this 3 over 5 root 2. All right, and now multiply by, you don't need to multiply by 5 root 2. You can just make it root 2. All right, now if you do 5 root 2, you're still going to get the right answer. All right, but I get 3 root 2 over 5 times 1, which is 5. Root 2 times 2 is 2. 5 times 2 is 10. And that's your answer. If you put 5 root 2, you're going to get the same answer eventually. You just have to simplify more. All right, so you just have to multiply by whatever the radical is, not what's outside the radical. That doesn't matter. All right, so the final answer is 3 root 2 over 10. Okay. All right, so now we have another one with a different type of root. Okay, so we have 1 over the 5th root of 8. Okay, I'm just going to rewrite this down here. 1 over the 5th root of 8. Okay, so I need to figure out what am I going to multiply the top and the bottom by. Now there's 2 ways to do this. Okay, I need this to be a perfect 5, whatever, fifth, something to the 5th power. Well, I have 8. So a lot of you are going to do this. 8 to the 1st. I want 8 to the 5th. So then I'm going to multiply top and bottom by 8 to the 4th. This would work. However, what in the world is 8 to the 4th power? I have no idea. Okay. And what's going to end up happening is you're going to end up having to simplify this later on. All right. So if possible, if you have a number like 8, what can you write 8 as? Can you write it as something to some power? All right. Well, 8 isn't it 8 2 cubed? So now it's a smaller number, easy to work with. I want 2 to the 5th. 2 cubed times what gives me 2 to the 5th? 2 squared, which is 4 and 4. 8 times 4 is 32, or 2 to the 5th, right? 84 is 2 to the 5th. And this is just the fifth root of 4. So my final answer for this problem is the 5th root of 4 over, this is just 2. All right. Now, what would have happened is if you would have got the 5th root of 8 to the 5th, that obviously this would be 8. You would have had 8 to the 4th, whatever that is. You would have had it broken that down into and simplify that, which is a little bit harder. So, and you would have had to know in your head what 8 to the 4th is. You're going to have to multiply it out loud because you're not allowed to use a calculator. So, if you see a number that can be rewritten as a smaller number to a power, do it. So, if this was 16, you could write this as 2 to the 4th. If this was 27, you could rewrite that as 3 cubed. If it was 64, you could write that as like 2 to the 6th or whatever, something like that. Okay. So if you can write a number as a, something to some power or something else, that's going to make life a little bit easier. All right. Now, a little something different with number 7. And you guys have done this before. We have a number plus or minus a square root. Okay. Now, we did this with imaginary. So hopefully you remember, what do you need to multiply the top and bottom by here? You guys remember? Well, what it is, it's something we call the conjugate. So the conjugate of 2 plus root 8 is 2 minus root 8. Right? 2 minus root 8. Okay? So I multiply this out and I get 4 times that. So it's this. Right? So 4 times 2 is 8. Now, could you simplify the square root of 8 first? Yes. I'll show you that in a second. And then minus 4 root 8, which we will simplify. All right. Over. Now, when you multiply conjugates, you just do 2 times 2, which is 4. Root 8 times root 8 is 8, but it's 4 minus 8. All right. Now, if you remember, so we have 8 minus 8 is 2 root 2, which is really, that turns into 8 root 2, all over negative 4. So I can simplify this and get 8 over negative 4 is negative 2. Negative over negative is a positive. And I get negative 2 plus 2 root 2. And there's my answer. All right. If you wanted to change this to root 2, same thing ends up happening. Okay. So you get negative 2 plus 2 root 2. So you multiply by conjugates. Make sure your final answer, if you just left it with root 8, it'd be wrong because you can simplify that. Make sure that you simplify all radicals in your final answer. All right. 8. See if you guys can go ahead and figure this one out now. All right. You should be multiplying by the conjugate, which is the square root of 3 plus the square root of 7. All right. That should get rid of the radical. If it doesn't, we did something wrong. Okay. So we multiply and I get 5 root 3 plus 5 root 7. It's not square root of 15 plus the square root of 35. Outsides and outsides, insides with insides. All right, now, root 3 times root 3 is 3. Root 7 times root 7 is 7. All right, remember, all right, the reason the middle terms cancel out, because if I did root 3 times root 7, that is positive root 21. Then I did negative root 7 times positive 3 would be negative root 21. They would always cancel out. All right, so I get 5 root 3 plus 5 root 7, all of that over a negative 4. Good. All right. All right, last two. All right, now, what you have to be careful about with these problems. This is 2 root 2 to the 5th. So this means 2 root 2 times 2 root 2 times 2 root 2 times 2 root 2, and get the idea, and one more time, okay? So the common mistake here is to forget to put this fifth power to the 2 as well, because it's 2 times 2 times 2 times 2 times 2, all right? Now, you should not have to write all this out. I'm just showing you what this means. So this is 2 to the 5th, and then what you're multiplying is really the square root of 2 to the 5th, which is the same thing as 2 to the 5th times the square root of 2 to the 5th. All right, the 5 can go in there. Remember, we talked about this when we were about like rational exponents. This means the same thing as that. So 2 to the 5th is 32. 2 to the 5th power, square root of that, all right, which is 32. But you have a 4 that should come out, right? Because it's 2 to the 5th. So you have 2 groups of 2. So that's 4, and then with 1, 2 left over, right? 2 to the 5th. 2 goes into 5 2 times. 2 2s are 2 squared is 4 with 1 left over. And then 32 times 4 is 128 root 2. All right. And our last one for the day is number 10. Why don't you guys give that a try? All right. So this negative, since we have a negative to the 4th power, it's an even power. The negative is going to become a positive, so we don't worry about that anymore. So what we have is 2 to the 4th, and then the square root of x cubed to the 4th, which is the same thing as 3 times 4, which is 12. So 2 to the 4th is 16. What's the square root of x to the 12th? Well, 2 goes into 12 how many times? 6 times with none left over. So there's nothing left in the radical. So it is 16x to the 6th. All right, and that's it for division. All right, so that's going to be it for new material before your next quiz, which I believe will be Wednesday. And that'll be the last thing we do before spring break. All right, so we'll be doing some review, practice for this today, and then some review for the next couple of days before we get ready for our quiz, which will be next week sometime, I think Wednesday. All right, enjoy the rest of your day, and I'll be talking to you guys soon.